When you see an object that is represented in this form, it is actually an isometric drawing. Isometric drawings are drawings that are seen in a three-dimensional view. Just like the sketch I made here, which is a brief representation of this. We are actually seeing this in a three-dimensional view, where we can see the side view, we can see the front view, we can see the side view, and we can see the third view, three-dimensional views. Now, our topic for today is orthographic drawing or orthographic projection. What is orthographic projection? Orthographic projection is actually projection or drawings that are represented in a two-dimensional view, unlike isometric, which are three-dimensional views. Now, transforming an isometric drawing to an orthographic drawing consists of three main views that are represented in a two-dimensional form. Firstly, we have the plan, the front view, which is this, or you can call it front elevation. We have also what we call the side view. Side view, which is this, or you can also call it end elevation. Then we have what we call the plan or the top view, which consists of these two. So viewing this object from this side, we would actually be seeing, viewing this object from this side, we would actually be seeing something like this. This is what we would actually be seeing, something like this. Now, remember, we call this our front view, what we are seeing. So let's just take it that, hey man, I'm asked to take a picture or view what I'm actually seeing. Let's just call this a wall. I'll be seeing this. Now, I am asked to walk from this side to this point to view this side view, which is this point. I'll be getting to see this here and here, which is this point and this point. So seeing these 2 points, I'll be obtaining this as my view. This area would actually be longer than this area. You get the point? Now, if possibly there is a building which I climbed or a tree, to make my top view what I'm actually seeing on top. Now, I'll be seeing this point and this point, which is this. I'll be seeing this point and be seeing this point, which what I would actually see is an image that is represented like this. This length would be longer than this length also. Now, in isometric, in orthographic drawing, there is a first angle projection and the second angle projection. So let's just call, we have this, let me just make a sketch. So we have this, here is our top view. This point is our front view. and this other point represents the side view. In a projection where the top view is at top, this projection is known as a third angle projection. Where the top view or the plan is at the top, where the plan is at the top, such a projection is known as a third angle projection. So in we have seen this as third angle projection. We also have what we call a first angle projection. Is actually the opposite to the third angle projection. Where we have the side view, we have the plan, which is also the top view, top, and we have the front view. So in this scenario where a projection is represented in this form, where the plan is at the bottom, then the front view is at the top, it is called a first angle projection. So getting to understand what an orthographic projection is actually a representation of a third angle project of a 3D view of an object in a two-dimensional view. Now, recalling what I actually said, here is our front view. This diagram here represents our side view, and here also represents our plan. Now, in a third angle projection, the front view is being represented here. The side view is represented at this point. The plan stays at this top. In a first angle projection, the front view is represented at the top. The side view is represented at this top. The plan is represented below. Now let's move straight to take this down into a real drawing to actually see what it looks like in a real drawing. So firstly, we plot out our straight vertical line. Just plot out the straight vertical line. Then we make it up also with a straight horizontal line. So getting to have these two lines at hand, we would actually measure out 1.5 from the center. 1.5 from the center, which is here is our center. We measure out 1.5 front, 1.5 back. So what does this decode? That the full length, let's get this, the full length from here to here is actually 3 centimeter from here to this point. So using the center point as an aid, we measure out 1.5 front, 1.5 back. We'd also come down a little bit to also do the same thing So we will join these lines all together. So we would also do the same application to the horizontal line, where we plot out 1.5 from up and down. So we have obtained these three lines that are touching each other. Now let's move to the main drawing. In this object which I have at hand, the full length of this object is actually 70 millimeter, which is 7 centimeter, because millimeter converting to centimeter is actually dividing that given value by 10. So 70 millimeter divided by 10 is actually 7 centimeter. So our full length would be 7 centimeter for the horizontal part. Then the vertical part is 5 centimeter, which we are having a 50 millimeter full vertical line, so it will be 5 centimeter. So we would plot out a 5 centimeter from this point. Now recall something very important. If let's take for example, in this drawing, let's take for example, there was an object on top. Let's say that there was an object on top from here. Now this object on top would be first drawn here. So let's say this is an object. Let's just make a brief sketch. Let's call this point, let's use this as an imagination, 3 centimeter. Now from this point to this point is 1 centimeter, which we know we have 1 centimeter here, 1 centimeter here. So this axis is actually the front view. We would measure out from this point, just make a brief measure out of 3 centimeter, a very thin line. Find where gives you your 1 centimeter, which is this point. You draw it down. Okay, let's call this point 1 centimeter also. This point is also 1 centimeter. You measure out your 1 centimeter down before you now enclose the remaining 1 centimeter, which at the end we would see this, which is being represented here. So if any object is at the top, from that top, that is where your projection would start. So now we are having this. From this top, we would measure out 5 centimeter from here. Now 5 centimeter from here gives us this as our 5 centimeter. You use a thick line because this is actually the image you're representing. You represent it with a thick line. Now our horizontal line here gives us 7 centimeter. On a safer side, you can obtain your 7 centimeter, indicate where it stops from here. Also plot out similar thing, 7 centimeter from this point. can now compare if the two are aligned. If they are not aligning, you know that there is an imperfection error, an error out of imperfection. So let's just make our drawing. So we have drawn our 7 centimeter. Now the height from here to here, from this point to this point, gives us 35 millimeter, which is 3.5 centimeter. The height from this point to this point. So we would measure out 3.5 centimeter from this point. 3.5 centimeter gives us this 3.5 centimeter. You measure at 3.5 centimeter. 3.5 centimeter also gives us this. Now, from this point to this point is represented as 40 millimeter. The length from this point to this point, which is what? 4 centimeter. Represent your 4 centimeter. This point, you note your 4 centimeter. So we would obtain this. This is at 3.5. Then our 4 centimeter, which is this. This is a 4 centimeter. Now, from this point to this point, we are left with what? 15 millimeter, which is 1.5 centimeter. So we see we are left with 1.5 centimeter. You join this up. So we've gotten our side view, we have gotten our front view, we have gotten this front view of this object. So let's move straight to get the side view. The side view. Now I'm drawing actually in a third angle projection, where my front view is first at the bottom left. So my side view would be at this direction, at the bottom right, at the bottom right. Now in this representation, this is what we are seeing as a side view. We are seeing this point and we are seeing this point, which is this. We are seeing this point, we are seeing this point. Are you getting it? So this point would actually give us a straight line, and the distance from here to here, which is from here to here, is 20 millimeter, which is 2 centimeter. So you measure out your 2 centimeter on top. You measure out your 2 centimeter. Then the height, we are still using this height as our representative height, which is 5 centimeter. So we use our 5 centimeter. Let's just enclose this once. So we have gotten this shape. Now this point to this point is greater than this point to this point. Now this point to this point is represented with 35 millimeter as the height. So we would locate 3.5 centimeter. We will locate 3.5 centimeter from this point. we enclose or we join those 2 points together. So we have gotten the side view of this object. Now moving lastly to the plan, which is the top view of this object, what we are actually seeing on top. So that is the representation here. We would see this, the two plans. So we are still using this given value. We would measure out 2 centimeter, then the full length, which is 7 centimeter. The full length of this is 7 centimeter. So we measure out 7. So from this point to this point is still 4 centimeter. So we measure out 4 centimeter. This point and this point, we join them and I get this point, this point. We have completed this drawing. We have actually represented this given object in a two-dimensional form, which is an orthographic drawing. Now, most importantly, your projection from the center point, your projection of 45 degree, you can use your protractor to measure out that, but from this point crossing to this point to gives you your 45 degree angle. So from this center point, most times some students actually project from this point. They just project from this point. No, you actually project from the center point, crossing this point also gives you your 45 degree line. You project out. Now projecting out, we are going to make an intersection of this point to actually show us here that this point here is still the same point at this side, just in another view, which let me move on so you could understand what I'm actually decoding. So with a faint line, a very faint line, you make a projection that touches this line. Now if your 45 degree is actually correct, like the two lines will align itself, it will align itself without any problem. So this projection which I made here is actually explaining that this point, this object we are seeing at the top, is the representation of this at the side. Are you getting it? This is the representation at the side. Now you also represent this point to this with a very faint line, which is actually explaining that on this point cuts down to this point, which is this, that this point we are seeing here is still the same point at this point, which is they are sharing the same length and value. They are sharing the same length and value. Now you definitely join this, which is still decoding to you that it is just one whole drawing. You know, there are sometimes some people will see this and feel like this is a three different drawing on its own, but this is actually one single drawing, but in three different views. In three different views. A single drawing that is represented in three different views, where we have the side view, the front view, the side view, and the top view, front elevation, side elevation, and plan. So I have actually represented this given object. So next video I'll be actually doing a drawing on orthographic drawing. I would actually bring an object that have a circular shape so that we would understand how a circular object could be represented in a two-dimensional form. Yes. So I thank you all for actually watching. If you found this video interesting, please kindly click on the subscription button. You can also share this video to your friends so that they could come also and learn. Thank you very much.